very first page, the bottom of the first page of that Master Math Mentor exponentials unit. And in case you're not in class, you can watch these, or if you want to watch them after class, that's okay too. So what we would need to do is solve these exponential equations. What's different about these exponential equations is we can rewrite the bases to be the same value, because I know that 2 to the third equals 8. So instead of having to use a logarithm or anything, I can just say 2 to the x plus 1 equals 2 to the third. And then because these bases are the same, it must be that those exponents are equal. So that allows me just to solve this one-step equation instead of having to do anything very fancy. So if I subtract 1 from both sides, I get x equals 2. And sure enough, if you substitute in 2 for x, 2 plus 1 is 3, 2 to the third is 8. So the same thing can happen here. I can rewrite 9 as 3 squared. So instead of 9, I can write 3 squared, and then 2x minus 3 has to equal 2. Add 3 to both sides, that gives me 5. Divide by 2, I get 5 over 2. And how did that check? Well, if you multiply 5 over 2 by 2, the 2's cancel out. 5 minus 3 is 2. Check. This one, I don't know if you know this, but 5 to the third is 125. So that must mean 1/2 x plus 4 equals 3. One thing we can do to get rid of the fraction is clear it by multiplying everything by 2. Don't have to do this step, but you can. And then I'm going to subtract 8. And that gives me x equals -2. And of course, if we want to check it, 2 times a half is, -2 times a half is -1. -1 plus 4 is 3. So for number 4, how do we take 1/3 and rewrite it so it's 3 to a power? Well, I'm hoping you remember that 3 to the -1, when you have a negative exponent, that means take the reciprocal. So that tells me that 4x minus 1 has to equal -1. And of course, if we add 1 to both sides, we get 4x equals 0. X has to be equal to 0. Nothing too difficult with that one, other than recognizing that it's 3 to the -1. Okay, so for number 5, we're going to do a similar kind of trick with the 1 over 49, because I know that 7 squared is 49, so I'm going to think of that as 7 to the -2. And then, of course, that's getting raised to the 1 minus x. And if we remember back from the work from Algebra 1 and from Algebra 2, when you raise powers to powers, you multiply those exponents. And that's, of course, 7 is being raised to that power, right? So since both of these are 7 to a power, it must be that 3x plus 1 has to equal -2 plus 2x. Well, let's see. If I subtract 1 and I subtract 2x, I get x equals -3, and I'm done in one foul swoop. Now for a twist with this one, I can't raise 9 to a power to make it be 27. However, 3 squared is 9, and 3 to the third power is 27. And then I can multiply those exponents. So I won't rewrite all this, but what I can do, I'm going to multiply 2 times the 2x minus 4 and the 3 times the x minus 1. And I will just rewrite that as 2 times 2x minus 4 equals 3 times x minus 1. And now it's just, I'm going to get rid of the parentheses, distribute through the 2, distribute through the 3. Then combine like terms. I move the 3x over here, move the 8 over here. So that gives me 1x equals 5. And that's going to be the solution. Okay, now this requires that you remember what a rational exponent is. I know that taking the cube root of a number is the same as rewriting it as to the fractional exponent, where the denominator of the exponent is the index of the radical. Remember, so if it's a square root, I can write it to the 1/2 power. It's the fourth root, I can write it to the 1/4 power. And let's see, then I've got the other side that's equal to what? 4 raised to the 5x minus